Resting membrane potential. This image illustrates the resting membrane potential, or RMP, of a neuron. Membrane potential is the difference in electrical charge across the neuron's cell membrane. When a neuron is at rest and is not generating an impulse, its membrane potential is typically about negative 70 millivolts. This means that the inside of the neuron is more negatively charged than the fluid outside the neuron. The resting membrane potential is produced by an unequal distribution of ions across the cell membrane. Outside the neuron, there are higher concentrations of sodium ions and chloride ions. Inside the neuron, there are higher concentrations of potassium ions and negatively charged phosphate ions. The cell membrane is selectively permeable, meaning that some ions can cross it more easily than others. At rest, the membrane is much more permeable to potassium than to sodium. Potassium leakage channels remain open, allowing potassium ions to diffuse out of the neuron. As positively charged potassium ions leave, negatively charged phosphate ions remain trapped inside the cell. This causes the inside of the neuron to become increasingly negative relative to the outside. A small amount of sodium may leak into the neuron, but the membrane allows much more potassium to move out than sodium to move in. The sodium-potassium pump also helps maintain these ion concentration differences. Using energy from ATP, the pump transports 3 sodium ions out of the neuron and 2 potassium ions into the neuron during each cycle. Although the pump contributes slightly to the negative internal charge, its primary role is to preserve the sodium and potassium concentration gradients over time. Together, ion distribution, selective membrane permeability, potassium leakage, and the sodium-potassium pump establish and maintain the resting membrane potential of approximately negative 70 millivolts. The resting membrane potential stores potential electrical energy across the membrane. It prepares the neuron to respond to a stimulus and is essential for the generation and conduction of nerve impulses.